Good afternoon, everybody, and welcome to our latest webinar, Unlocking IT/OT Integration. Before we begin, just a few housekeeping points. This session is being recorded and will be shared with our members and attendees. So if you need to step away during today's session, you can catch up later. The recording should be available within 7 working days. To minimise background noise, all attendees are muted, but we do encourage interaction through the Q&A feature, which you should see at the top of the screen. So feel free to submit questions at any time, and we'll aim to answer as many as we can during the dedicated Q&A session at the end. If you experience any technical issues during this event, Microsoft Teams can often be corrected by refreshing your browser or just leaving and re-entering. You can also use the chat function for assistance, and I'll look to support where I can. And that's all from me. I'm now going to hand you over to Ben, who's the solutions engineer at ForSecure, who's going to be hosting today's event. Over to you, Ben.
Thanks very much, Dom, and good afternoon, everybody. So we'll just go through a quick introductions of us speaking today, and then we'll do an agenda, and then we'll get cracking on today's topic of protocol interoperability. So I'm Ben Jennings. I'm a solutions engineer at ForSecure, the background in providing secure data transfer solutions into government and defence in the form of cross-domain solutions, and working with secure data import and secure data export throughout critical national infrastructure and wider OT and IT environments. Peter, could you introduce yourself, please? You're just on mute, I think.
Hello, everybody. My name is Peter Herdman. I'm director of my own company specializing in OT ICS cybersecurity. I've worked in ICS cybersecurity for about 10 years, cyber in 20 years, and prior to that, I worked primarily in the SCADA industry across the water sector.
Perfect. Thanks very much, Peter. And Anthony, could you introduce yourself, please?
Yes, I will. Hello, everybody. My name's Anthony Nichol. I'm the director at Unilever for cybersecurity, security engineering. My background isn't cyber. My background's manufacturing. I've been in manufacturing probably 37 years, but probably cyber 7 or 8 as part of a digital journey for the business. So I drive a strategy for the cyber program for factories, warehouses and R&D. Thank you.
Thank you very much. So moving on to the agenda of what we're going to be discussing today. We're going to start with just understanding OT landscape and really homing in on the kind of priority differences between OT and IT, because that then really forms the basic for understanding the protocol challenge that we have as data moves from the field in OT to the cloud. We're then going to talk about the operational and the security benefits that organizations can have from using protocol interoperability at different points across their ecosystem. And then we're going to talk about how network security and network security boundary architecture comes into that topic. And then we'll talk about the art of the possible if we combine those two together, before then moving on to an audience Q&A for the last 10 or 15 minutes or so. So diving in then, understanding the OT landscape, operational technology in the simplest form refers to hardware and software systems that monitor and control physical devices, processes, and infrastructure. So it's everywhere. So to rattle off a few: manufacturing lines, power plants, oil and gas rigs, water treatment facilities, mining operations, building management systems, railways, airports, shipping ports, healthcare equipment, food processing, chemical plants. It's all operational technology, and really OT is the backbone for lots of those environments and essential for their reliability and for them to run efficiently. So whilst OT is very broad, that's not to say the scope of OT is limitless. So Peter, I'd really like to start with you. Do you think that everyone has the same definition of OT? And what are some preconceptions and perhaps misconceptions that you see with defining the scope of the OT landscape?
Yeah, it's a good question, because if I look back about 10 years when you mentioned ICS cybersecurity, often people would say, what's ICS? And you say, well, it's industrial control system. And there was little interest in the topic until some headline news stories. And then I think InfluxDB and, CISOs became aware of it. And the term was used OT. And I think that slightly misleads often IT departments who, in my experience, often believe it's either laptops that are used in a industrial environment, or it's a laptop in an industrial rubber cover or bumper to make it secure, and not realize that typically in a manufacturing plant, out of 1,000 OT assets, only 100 of those assets may be, COTS servers, Windows or Linux servers. Literally everything else will be something a normal IT person won't even recognize.
Yeah, interesting. And then Anthony, kind of expanding on that then, what are some of the challenges, particularly around obsolescence, that are inherent with OT that perhaps those people who have sort of careers in IT wouldn't be familiar with? What are those big obsolescence challenges?
Well, I think when just going back, maybe even 20 years or even 10 years, wherever you want to go back to, control systems, packing lines, water treatment plants or whatever, were all built with the concept of execution and not to be talking to other parts of the business. It was very isolated. The life cycle of a machine in, say, Unilever or other manufacturing environments are 10 plus years. I know in other industries as well as mine, you could have systems that are still running 30 years on. So life cycle. Also, the other challenge is that the majority of factories would not be considering a maintenance contract for patching, because why would you want to patch? Because you're isolated from everything else. You're just running isolated systems. No one touches it except for the user. So there's never been a need to maintain or provision for updates. And this is a challenge now because we've now got a legacy of systems that haven't been upgraded. So therefore the cost and the return on investment for that change is very big. And remember that you could say, well, hold on a minute, operating systems are very cheap, Anthony. That's not a challenge just to replace it to Windows 11 from Windows XP. Well, it is, because the application that sits upon it normally costs me about $750,000, or $250,000 to $750,000 to upgrade a SCADA system, supervisory control and data acquisition system, that's controlling a process plant, a packing line necessarily. There's a big investment, and there's no return on investment to get that back, because when we built it, we didn't need to connect. Now we've decided that we need to connect. Now we're more vulnerable. So big challenge is that spend. The accountants run the business, and you've got to have justification for replacement, and it's very difficult. Is one of the big challenges.
Interesting. So then expanding on that that legacy aspect further then, Peter, and starting to think about security, what are some of the inherent security vulnerabilities of OT data, of OT systems, kind of off the back of all that legacy challenge that Anthony's just talked about there?
Well, it is very much that, and it's I think if you look at any statement around differences between IT and OT, it is the fact that they're using a lot of insecure protocols and not inherently designed with security in mind. But because of innovation is maybe 5, 10, 15 years ahead of the technology. And you have, manufacturing plants striving for efficiencies, wanting to use, SaaS services. So it is protecting, it is literally that boundary. That's the fundamental control that we need to put in place. Everything else is applicable as it is in IT security, but protecting that boundary control, which has historically never been crossed, or limited connections across it for maybe some support. But for operation, it is becoming a common, almost business as usual requirement. And that requirement usually comes from a automation vendor that says we need any outbound port protocol and service connecting to our service.
Yeah. Okay. So then talking about that change that we've seen come online more recently then in the last few years, and that desire for more integration and the changes around that. Anthony, in your view, how has the role of OT data, the value of OT data, how's that changed in, say, the last 5 or 10 years? And what really is driving that change?
Well, I think just to go back, I'm going to answer the first or last question, but in the last 10 years, we've needed to look for creative release of productivity, I would say. And we've been spending many years doing TPM in factories and manufacturing environments, trying to get lean manufacturing. And we've kind of run out of the old way of getting value. So what the data that we can get from the factories, whether it's a sensor or whether it's an index of a machine, the value that we can get that we've never been able to get before because we didn't have the compute power was to look at almost like unknown values that we can get. Either it's tuning a packing line, it's predicting predicted maintenance, whether it's OEE efficiencies through to right first time production. This all releases back to my earlier problem that I have. I've got no money to do this. Digital is digital way forward, and the connecting of that data that's previously been isolated is the real value for the next 5-10 years for the business. If you don't digitize, you won't be in the business in manufacturing in the next 10 years. So you have to do this. I'm going back to some of the other challenges I didn't mention before. Suppliers, the system integrators that supply the kit in the factories don't have the skills to understand security, often don't understand networks. So, but the real value coming out of this is we can get big, capital avoidance is one of the biggest ones I've seen where you get a big, massive saving. You might have to put a new packing line in for 3 million to 5 million or a process plant in for that kind of number. If you can optimize that plant, whether it's predictive maintenance, whether it's optimizing quality at right first time, then you can save 10 million per process plant, capital avoidance, and that is big money for the business to keep going, and it feeds into their profit margins and their margins, so they can advertise, so they can grow. Key message here is if you don't do that, and we don't do digitization, then we're not, as I say, I'll repeat, I don't think we'll be in business in 5-10 years time. That's the shift. Downside is we're going to get more vulnerable because we have to connect.
Interesting. And you mentioned not having the compute power historically as being one of the reasons why we haven't been able to do this, or organizations weren't able to do this a decade or two ago. But Peter, is there any other reasons you'd like to add as to why it's taken longer to really unlock the value of OT data over and above just not having the compute power?
Well, I think it's the actual logistics of it become a challenge, because when you want to connect OT, and again, I'll speak for manufacturing because maybe it's a good point to highlight. There's different priorities in critical national infrastructure, nuclear power generation, gas to manufacturing. So it's a different approach you may take. All of them have their different challenges. It's understanding who can help connect manufacturing. There was I've seen it often distinct vagueness in responsibility of who owns the network. Well, if you go into many manufacturing plants, it's developed organically by the person, the engineer who's known a little bit about IT. And if you think back to IT in organizations when PCs first became popular in business, it was the person who knew about it who was responsible for managing that environment. So you have this organically grown, badly or no design network, and you have a well-managed corporate side, and there's really no interface between those two. There's no collaboration, and that there's been a requirement, but a difficulty in the logistics, collaboration, and understanding of responsibility of who's going to design this solution, because they're in two different worlds.
Interesting. And that leads us on nicely then to just sort of finally focusing on some of those priority differences a bit more before we get into protocols. So we've got on screen here what are typically the differences in priorities on OT on the left there, being more about availability and safety, and IT on the right there, being more about confidentiality and integrity. But Anthony, with someone with masses of experience in manufacturing, talking from your experience at Unilever, how do the priorities stack up for you between OT and IT in your environments?
Well, the priority for factories is, again, I think I'd only add on your slide quality. And when you say availability, for me, these are always the priorities of the factory. Safety first, everybody. Anybody that's in manufacturing would relate to that, I'm sure, in any environment. But the priority has always been availability. Remember, we don't have personal data in factories, and we're not necessarily even focused on confidentiality, because I don't have any personal data. I've got maybe some product data, which is probably on the side of a pack anyway. So there's nothing really confidential. And my availability understanding is different to IT's. I'm running production that may be running 24/7. And where an IT system turned off, if Teams turns off, we lose this call, right? No one's lost any money. We might have lost valuable information, but we won't have lost any money. Whereas if I shut down a factory just to do a patch or an upgrade or something, there's a bigger financial impact. You could argue that it might be not direct, but there is a bigger impact on availability. So clearly, my priorities in a factory is keep it running and keep it reliable and safe, producing quality. And confidentiality is not even really in my interest in normal. Some people on this call may say we have got confidential information, but it's at a lower level in OT, certainly.
Yeah. And then talking then kind of these different priorities, these integration challenges, that's really, really interesting. Peter, how much of this then is technical? How much is organizational? How much is cultural? Where do you typically see that balance between those of trying to get these two systems to work together?
Well, other than sort of remote access, typically for some of the use cases in OT, it's rarely a technical challenge. There's always some technology that you can find that meets the requirements. The cultural challenge is huge, and I often use the analogy when I speak to engineers. 20 years ago, you might find somebody standing on a pallet on a forklift truck getting lifted up to change a light bulb. Well, health and safety now, they wouldn't even think of doing that. But they don't think twice about just taking a USB stick from home, using it. And it's very much cultural. I think if there was one thing I could change, it would be, culture. And from experiences in IT, there's no quick fix to that. If we think even with the general public 10 years ago, privacy wasn't a priority for the general public. Now everybody is aware of privacy, GDPR, protecting data, and I think we've got some way to go in the cultural journey.
Yeah.
Just to build on the culture thing, though, just to build a little bit further, I think when I talked about system integrators and suppliers and skills, there's a culture outside just manufacturing across the supply chain. The people that look after OT and maintain it and install it don't have a concept of the interconnection and the requirement and connection to clouds, because that's IT skill set. So please, let's make sure we understand that the system integrator in IT is the big suppliers. I'm not going to name them because we're not here for advertising, but we all know the big IT suppliers. In OT, the culture is you put it in and walk away. You don't maintain it. The suppliers have no clue about cloud, and I'm not insulting anybody, hopefully, on the call, but they don't consider it in their installation and the maintenance related to it. So it's something culturally that needs to change across, not just within companies, but in the supply base that support the companies.
Yeah. And that's really interesting, and that leads us on kind of really nicely to talking about protocols, because these OT protocols, those industrial control systems, these protocols were never really built to leave the plant. They were built to stay inside the plant. They were built to do a very specific function, and we've got on screen there a sort of table listing a number of those key differences between OT and IT based protocols, which all kind of tie in nicely with everything that both Anthony and Peter, you both said there about those different differences. Kind of open question here, Peter. Anything you'd like to add or expand on what's in the table there and those key differences in protocols?
No, I think it clearly articulates there is a different plant floor protocols to more of the IT based data protocols. No, nothing really more to add to that one.
I think from my perspective, just to build, let me just think about some of the Profinet, so people probably understand what I'm saying on MTQ2, all the different protocols of OPC, UA, etc., which we're well, okay, on here, MQTT, etc. Think about these protocols as they were master-slave in the olden days, right? So a machine is talking to another machine specifically in a proper conversation. You might have poor network connectivity, which is probably why MQTT was invented in the first place, because you wanted reliable connectivity. So it failed. If the network failed, it bounced back and still gave you the information, because the reliability of that signal is so important. So in the factories environment, and I'm talking about utilities as well, you need the reliability of that information. It's driving safety systems. It's driving critical systems that require accurate response. So it's about speed. It's not about bandwidth. It's not about amount of data. It's about being able to simply handshake with me and Peter with the communication so that we can keep things running. And all these protocols are probably older than most of us, or have been around as long as most of us, and are very reliable. And you wouldn't depend on a Windows system necessarily to run some of the safety systems. And these protocols were designed to support reliability. And that's really key in the messaging that the OPC, UA, and QT were all developed for reliability, so that your systems were supported for resilience. Whereas for me, IT is built for high bandwidth, kind of like lots of information, lots of data transmission. That's not what these protocols are about in the factory. I think they call them field bus or whatever you want to call them, mod bus, but they're about very close. In fact, when most of them were invented, the internet wasn't even in existence. Okay, so the concept of leaving that building was not in the construct of those. I know they've developed since, but that's what they were built for: peer-to-peer or master-slave. Sorry, hopefully I answered a bit of a question there, maybe jumped.
No, that's really, really good. And yeah, that kind of is, this slide here is articulating for, for those who work on one side or the other, that somewhere on here will be familiar logos to everybody. If you work on the IT side, I'm sure you've interacted with the cloud platforms on the right-hand side, but really what this is showing about is how these different protocols and platforms providers change as we move from those OT field serial-based, proprietary-based protocols that we've got some of listed on the left there, as they move to then being kind of message queuing-based protocols, onto what are then the platforms that provide a single pane of glass to the user, and then increasingly that's when we're seeing them in a cloud environment. And Anthony, you really touched on the kind of operational side of what these OT protocols are for. But Peter, just then sort of with the security hat on that, can you expand maybe sort of at a slightly more technical level, what are some of the immediate security challenges with those older OT protocols that we've got listed on the left there that we don't have on the right?
Yeah, absolutely. And it's mainly that a good reference architecture for OT connectivity is more constrained than you would typically see in a enterprise or corporate environment. You'll have segmentation based on, security impact levels of the different parts of the plant. And as you move into the sort of to the right of that diagram and those protocols, they don't always work well crossing, physical security control boundaries. And you sort of and you cannot have really wide open. If you take cloud, for example, it's very difficult to pin down to a single, fully qualified domain name, an endpoint in a cloud environment to send data to, because while it might work for 5 minutes, the next time you look, you'll see it being blocked if you're using it sort of, a next-gen firewall, because the destination will have changed. There'll be a unique identifier appended to it, or it will move around. And the level of connectivity required to connect to the cloud is really not consistent with good practice for, very robust and strict ingress and egress filtering in a production environment.
Yeah, very interesting. So then sort of continuing the conversation, kind of more technical and sort of architectural, what we've then got here is mapping those protocols out to the Purdue model. And what we can see here is on our level 0 and level 1, we've got our serial and proprietary based protocols. As we start to have aggregation and we start to bring SCADA into play, we've then got kind of versions of those protocols that have been adapted kind of after the fact to work over TCP/IP, so Modbus and DMP3. As we keep then moving to kind of a more wider historian and bringing more data, we start seeing those message queuing protocols. We start seeing larger databases and of course OPC UA. And then as we move out of our kind of DMZ into our cloud, that's when we see the cloud-friendly protocols that organizations or cloud platform providers have really built those platforms to work with, the likes of Kafka, the likes of MQTT, AMQP. And there is, what's becoming interesting is there is kind of a level of native integration that's often possible. Increasingly, OT environments are having sensors and endpoints that support that MQTT, perhaps support a REST API push. But as we've kind of mapped this out to the Purdue model, I'd really like to get your thoughts, Anthony, on the Purdue model as a whole, given its sort of inception back in the 90s. Quite a lot of opinions that go around about how relevant it is today. What's your opinion on the Purdue model as a best practice for an architectural approach in 2025?
I think my view only would be that it's relevant. It's still relevant. And again, I've been in many forums where they'd say it's not relevant, and I'll explain why they might say that in a second. But it's very relevant to me in that it allows us that segmentation that a lot of legislation and regulation, 62443 or whatever, is trying to talk about, segmenting OT from IT and guidelines, and NIS2 coming in saying we need to understand how we segment and support and document. This is a really good way of mapping that out. And again, going backwards, we're very strong in asset management and management, like I said, in level 4, but level 0 to 1, so to 3, sorry, you're going to find varying levels of network connectivity on managed switches. So it's really good if you want to start a journey like we've been doing, is prioritizing. You can't do everything at once. This for me allows you a prioritization process and a segmentation perimeter mindset that allows you to go forward. The challenges that many people on this call will say is, yeah, but the new world's about IoT and you can plug it down at level 0 and it bypasses all that. Yep, but it's only one-way traffic and it's only going off. But this still gives a framework for prioritization and a roadmap to drive connectivity and security within an environment. So I think it's still relevant. I'm not saying it hasn't morphed slightly differently, but if you was on a journey, this is a really good foundational understanding back to what we've just talked about. Again, the two different people. We've got this culture change again, and this helps. It helps the IT people understand OT, because I've briefed this out on many occasions, and IT have kind of the eyes have opened and understood a little bit more. And when I'm talking to IT people, they want to touch level 3 and maybe level 2, and they don't want to touch level 0 and level 1 in security. What they might want to say is it's a kind of helps people slice where you want to go on that journey to this convergence of IT and OT. Will an IT person ever look after level 0 and 1? Not in the short term, maybe in the long term, but for now it's about helping people understand that convergence and where we can do that on as a roadmap.
Yeah, okay, so still very much a relevant principle for today. And then Peter, then talking about the change in technology, say the last decade or so, what technologies in the last decade that organizations are really adopting affect the Purdue model and the security fundamentals that it preaches? What changes?
Well, there's been a huge shift, and that model is really good for trying to, think conceptually of how you should construct your communication path. But what we've seen, where if we go back again, historically, you maybe had some huge suppliers in the automation industry, Siemens, Rockwell, Schneider, and many more. What I'm seeing now, and requirements coming into me from engineers and different plants, they've been to a conference, they've come back, they've already purchased equipment, and indeed I've got some devices that are down at level 1. They've got a sensors connected, they have Bluetooth, they are Wi-Fi access points, they have a web server, they have a web interface, you can put a 5G card in them. They can do everything, pretty much everything at many other levels. And the requirement from that manufacturer, who often startups, the way people have started made, developing apps for your phone, almost a cottage industry. We're seeing this now with, industrial Arduinos, industrial Raspberry Pis. Everybody is starting up and coming to the automation industry. And I was at Utility Week, and the startups are pitching their products, and they're saying, you just put this, it'll do all of this, and it just needs internet connectivity to our cloud. And that model then, where you say, well, we've got these zones and the Purdue model to consider for how you should communicate, and zones and conduits, and they haven't even heard of this concept. It's just put a 5G card in, connect it, and then it's an access point to the rest of the network as well. So I think there's a huge gap between, innovation and sometimes, again, the culture. I think Anthony touched on it, supply chain culture around how automation, and I think there's a lot more rigor around critical infrastructure, but in manufacturing, you do see, it's about productivity.
And on that lack of, consensus then that we see from a security standpoint of people who make some of these equipment, but particularly on the cloud side as well, people who are making or developing platforms and applications to work in the cloud, perhaps not conscious of the same priorities in OT. One thing that I've seen come online quite a lot in the last couple of years is cloud data analytic platforms offering kind of support for some more traditional OT protocols. I've seen sort of plugins that can be available that say, oh yes, we have a plugin that will allow you to tap into your OPC UA server. So no more do you have to try and present the data to us in a format that we can understand. We've got a plugin in the cloud provider platform that can talk back into your OPC server to get that data out. And there are kind of a number of considerations, both operationally and security with that. And from an operational perspective, the platforms kind of weren't really built for that protocol. So that can introduce performance challenges. But then there's also kind of an extra licensing cost for that plugin, as well as kind of vendor lock-in. And then what we see is the kind of DIY approach that can then happen to try and natively integrate environments where, say, OPC is present on both the cloud IT side and the OT side. So there can often be kind of the advertisement that there's a quick win to plug a cloud platform into where the data is on the OT side. but there's some real operational challenges with that. All of that said, the security challenges really are much greater. And what we've got on screen here is an architecture that may happen if we have, for example, a cloud provider platform on the right-hand side with a plugin for a protocol like OPC UA. It's got an OPC client, and in order to connect and get the data that it needs, it's connecting inbound to where that OPC server is. Now, the big no-no, sadly, we do see it, is an inbound connection all the way into the OT environment. And that then immediately increases our attack surface because we've opened up a point of entry for an attacker to get into the OT environment. Or sort of better scenario, an inbound connection into the DMZ, but still we can kind of improve that security posture and align to more kind of best practice frameworks if there aren't inbound connections where possible. So this is just to sort of highlight that integration may look straightforward if a cloud provider has a plugin that can deal with a protocol, but actually there's both operational and security architecture concerns specifically around that inbound route, that inbound firewall rule that we need to be really conscious of when those kind of quick, easy integrations are advertised. And that leads us on to then sort of talking about middleware and the role of middleware as data moves from OT to the cloud. Middleware has some sort of quite different definitions to different people. It can do lots of different things. Peter, noting that it's such a broad term, how would you define middleware yourself?
Well, I define it as a component, a software component that takes two different non-compatible, if you want to call them protocols or services or systems, and allows them to share data in both directions.
Yeah, okay. And then UNS, unified namespace, talking about a UNS architecture. Perhaps for those who don't know what it is, if you could just give an overview as to what it is, but how does middleware support that UNS approach?
Well, yes, this is rapidly developing, and it's one of those concepts where it's about compatibility. And if you think, just visualize a hub and a spoke type of architecture, but not hub and spoke, but just in your head for how things can communicate. If things are UNS compatible, then they can communicate. And we've seen this in the IT industry, where large players in the industry collaborate and agree on a standard. And I think this is one approach to trying to address that problem, as opposed to having just proprietary sort of modules for different protocols to communicate. It's an almost out of the box solution, plug in and go type of, for devices and systems to talk to each other.
Yeah, okay. And then Anthony, to give our audience a bit more kind of real world context to this, could you, are there any specific use cases enabled by kind of middleware technology that you'd be able to share with us at Unilever, kind of what it looks like in the real world, what it's enabled?
Well, I think first, I'll start backwards again. Unified namespace is good for a new factory, difficult for a brownfield site to implement. It's very difficult as a journey. What we've done in the past, not just Unilever but elsewhere, but Kepware and Ignition, we've used them as that, I call it the translator. They say we're talking one industrial protocol that can convert it and transform it into IT speak. The problem is you tend to need specialists on different systems. So if I've got 10 packing lines and a process plant or 2 process plants, I'm probably going to need 3 or 4 people that I need to get involved with. It's time consuming, it's tailor made, it's then just set up, and then you need maintenance. It kind of feels clunky, if that's the right word. Maybe it's not a technical word, but unified namespace is the future, where everything talks to everything. And I don't need a specialist. I don't need a Peter Herdman and Anthony Nichol to come in and do that interconnection. It's plug and play. It's Windows 95 plug and play in the factories, if you want to put it as an analogy. And I think middleware plays a key part in that transition to get that data to do all the value that I talked about at the beginning. Again, going back to all these different suppliers that I've had to deal with in my supply chain, we have to get them all involved. So at the moment, middleware is still a tough task to implement. Unified naming space will make that life easier, and people will be able to plug it in and set that comms without having that specialist. So it de-skills the infrastructure that we need currently in a lot of our brownfield sites. Is one of the things that I like to share. Yeah.
Yeah. Okay. Absolutely. So that's a really good kind of picture then of operationally what it does for users. Discussing then back kind of on the security side, we've got on the slide here with what we can change architecturally as a result of middleware as well. So going back to our previous example, where the OPC data needed to get to the cloud environment, onto the cloud platform, with the use of middleware, what can then happen if all of that data, all of those data points are transformed into one unified format? They can then be tunneled outbound from the OT environment, from the DMZ environment. And what that means is then that is just an outbound only connection. So there's no inbound firewall rules. We've not opened up our attack surface. So by taking all of those data points, unifying them into a set format, tunneling them outbound, we solve a security problem, as well as all of the operational challenges and problem solving that Anthony's just touched on there. Moving the conversation then to network security. So having talked a lot about protocols and touched on architecture, what I'd really like to go into now is network boundary security, because I think what our conversation so far has shown is how sort of much alignment there is between protocols, protocol interoperability, and network boundary security. And the key point kind of being that the protocol choices and the boundary controls, they need to support each other, and they really go hand in hand. If they're not aligned, then the overall design becomes much more harder and less secure. So talking about then the spectrum of network boundary technology, we've got a diagram on the slide here, which talks about a series of, or sort of articulates a series of different technologies that can be used to secure a network boundary. On the left-hand side, we've got simple software logical controls, the access control list, the VLANs. As that gets more comprehensive, we then move on to more orchestration and, of course, firewalls and next generation firewalls, which have been the absolute center of isolation technology for the last 2 decades. As we then move further, we get onto a data diode, which we're going to talk about more in the next slide. But a data diode is a way of, or is an appliance that can move data one way between 2 networks, but that unidirectionality, that one-way connection, is enforced in hardware. And then at the very extreme, we have an air gap, not connecting 2 systems. And what I'd like to talk about here is briefly the kind of government military defense stance on this technology, because I think that world is very interesting. In government defense world, they all have to adhere to the government security classification policy, the GCSP. And what that policy says is if you have secret data on a secret network, you cannot connect that network to another network. So that network must remain air gapped. The only exception to that, and the only technology that can be used to get data into that network, is what's referred to as a cross-domain solution for moving data between security classifications. And in almost all cases, in the middle of that solution is a data diode. So Anthony, kind of given the kind of how much government and defense world sort of preach the data diode as a technology, how does that translate to you in your industry? If or what value do you see that a data diode would have in the world of manufacturing in your world?
Well, in my world today, I don't use a data diode. And the reason why I don't air gap as well, and I'll put you together just so that I'm not pointing just at the data diode, is the air gap is too expensive for us for a start. For us to fully isolate our factories from our IT is an ambition, but we really struggle. Even security tools require the ability to connect, whether it's an EDR tool or an NDR tool. We still need connectivity towards the factories. So having air gaps is not really our option. The other problem with, and the reason why I probably don't use a data diode, I don't think that's cost as such, but I need remote access within my factories. So I do like the idea of traffic going one direction, but it's been more of a cost. I don't even do the orchestration layer. I've definitely just gone for the middle road in my environment, was the firewall, because it was probably the easiest way for us to implement. I wouldn't say data dyers wouldn't be something we couldn't consider, but in our strategy at the time, firewalls were a far easier implementation of segmentation. And that allowed me
Understood.
then tools such as, whether it's Tanium, CrowdStrike, whatever security tools you talk about, allows them ingress into that environment to allow us some level of security. So maybe future data diodes, but for now in my manufacturing world, we're sitting at the firewall end.
Brilliant. And Peter, you've got a lot of experience across critical national infrastructure environments. So talking more broadly about CNI, what value do you think this technology could have for CNI environments?
Well, it's down to the fundamental reason we do cybersecurity. It's based on risk. So every instance has to be looked at on an individual case basis, and what's the risk. And then secondly, it's a security person's job to support business objectives by ensuring it can do what it needs to do as secure as possible, while that risk's balanced with the risk appetite and tolerance of the business. So everybody in IT security knows these fundamentals. So there will be instances where air gaps are required. There will be instances where data diodes are required or appropriate for the job to balance that equation, and there may be instances where that is too much and it won't help achieve the business objectives, and power generation, different objectives to making tins of beans or something like that. So it's the right control for the right job where it fits into that solution, and it meets all of the use cases or the majority of them.
Yeah, risk appetite, and that's absolutely a massive consideration in network boundary technology world. Risk appetite. What are you trying to protect? What does the outcome look like if this system or network gets breached? So just for those of the audience who aren't familiar with data diode technology, we've got an architecture on screen here. So it looks like a switch, typically a 1U network appliance. Within it, however, are two separate systems. So it's not just a component, it's not just a light emitter, it is a system that has, it's actually two systems inside a chassis, and those systems run software, and the software is the key to allowing the protocol adapters to work with two-way protocols across an appliance that ultimately only sends in one direction. So one of the systems in the boxes sits on the source network, which is typically a OT side where the data is generated. That interfaces with the systems on the OT network, could be a OPC server, could be a MQTT broker, in order to pull the information into that system. The data is then moved as a non-routable protocol across an optical fiber cable, which has a component only capable of sending light on one side and a component only capable of receiving light on the other side. So there's a protocol break there. So it's not a network packet at that point in time. It's typically ATM, asynchronous transfer mode. On the IT side, that is then with FPGA and hardware, that data, that payload is rebuilt into TCP/IP before then being sent onwards as a new network packet to the system where the data needs to go. So it's not just a component, it's a solution that has compute and software in order to allow two protocols to move in one direction, but in a way that is hardware enforced. So then kind of bringing that all together as the kind of the art of the possible in terms of what a gold standard architecture might look like if we're combining unified namespace as an approach and software in order to do that protocol interoperability, bring that protocol into a central format, tunnel that outbound, then with perhaps a hardware enforced network appliance as well. What I'd really like to get, so we've got a diagram on screen here of what perhaps that art of the possible architecture might look like. But what I'd really like to understand from Anthony and Peter, Anthony, if we start with you, what would you consider a gold standard architecture for OT and IT integration, and how much of that kind of reflects, I guess, to what we're looking at on the slide here?
I think the common advantage of we talked about at the beginning, OT and IT convergence. I think OT needs to start looking like IT, not necessarily managed by IT, but they also need to be separated from IT, because the risk of IT ingress and cyber attack is higher than OT, but the different impact is measured in the factory. If you shut down the factory, is a different cost to shutting down IT. But ideally, going back to the point you asked, having full air gap or full segmentation is the ideal world that we would want, right? Whether you're national infrastructure or whether you're manufacturing. What this data diode gives is the ability to not necessarily do fully, but still allow some connectivity, which is needed, as again, back to my insight to productivity. I need that information. So a full air gap is not a real choice for me. So we do need to look at some connectivity, and this brings that opportunity. I'm not saying I would use it necessarily, sorry, not to be almost showing it, but it certainly meets the objective of isolating as much as possible and allowing communication for my digital journey, whether I'm electricity, gas, water, or baked beans, as Peter pointed out earlier. And we need that connectivity, and we need that insight from the compute power in the cloud. So we do need some level of connectivity, in my view, and this does fit some of that, as well as a firewall would do that as well, though, just so everybody's clear. I don't think a firewall potentially is as attractive as air gap or diode, because when I played with firewalls, and Peter's probably got similar experiences, I'm always having to update it, software updates and all the rest of it. It's got a lot of management involved in that, managing firewall rule changes and etc. It's very difficult. So, but it still needs. Back to you.
Yeah, which brings us on to an interesting point that I'd like to discuss. So we've got a series of excerpts from various guidance on screen there, and one word that appears quite a lot across IEC, across NIST, is the word unidirectional gateway. And Peter, I'd like to come first to you on this one. But when you read unidirectional gateway, what does that mean to you? Does it mean diode? Does it mean firewall? Does it mean something else?
Well, in my mind, my first response would be a data diode, but the actual definition, one might argue, it's any device that only allows connectivity in one direction. So it's a difficult one to interpret. I haven't seen, I've seen the word data diode suggested, but when they use the term gateway, it's just connect it, restricting flow in one direction.
Yeah. And Anthony, any kind of difference of opinion on that? Anything else to add on what unidirectional gateway means?
Well, it implies with the word one direction. But going back to my earlier point, I still need to do remote access. So I still need to figure out, and again, maybe it's just a manufacturing thing. I'm not going to say I'm going to talk for other industries, but my skill set in my factories, we need third parties that understand the technologies, and I'm talking about the processing technologies that we don't understand, whether it's motion control, whether it's mixing powders, whatever. We still need their support, because if I'm in Argentina, I know we talk, and the German company put it in Germany, I can't fly them over. So ideally, I'll go back to the world. I do want to comply to NIS2, but again, it's got back to the risk and cost, and I operate my business. And I still think you need the ability. When I worked in the Water Authority, Peter, we used to use telemetry. That's how old I am, by the way. But we still needed to go turn things on and off remotely. So I can't imagine that everybody doesn't have the same need as me. So ideal world, the legislation and the guidance from NIS2 is exactly what we should want. That is the holy grail, the wish list. The problem is that we've got the need to go the other direction as well. So, and that's the risk that the business or the industry or whatever needs to assess and agree to. So I don't think I can comply to that requirement from NIST at this point. Peter, I don't know if you want to build on that.
No, nothing really to add to that, Anthony.
Fantastic. Which brings us quite nicely to our Q&A. We've got a few minutes left. Dom, I'm hoping I can hand it back over to you at this point to just run through some questions with our audience.
Yes, thank you, Ben, Anthony, Peter. Really good discussion. A few questions have been coming in. I'll go through in chronological order. Andrew mentions how much effort has gone into determining that change does not add any safety risk that may affect the company's license to operate. Who determines if any change management remains compliant with safety regulations?
Anthony, do you want to take that one?
I'll start. Clearly, and this is this IT/OT convergence, and we've started on the journey, and we've seen IT saying, "Oh, we need to use this and we need to use that safe, cybersecurity tool or whatever," and we've had to say that's not necessarily. We've been challenged on a number of occasions on safety systems, but I think to answer your question, Andrew, a lot has been considered in my environment to understand that. What I've seen is that IT, sorry if anybody, most of you be IT based anyway, would maybe not understand the importance of going back to those protocols I talked about at the beginning, the reliability of that information. And we have considered it, and we leave the risk with the sites or with the business groups to make some of those decisions on health and safety, because safety is first. So sometimes people are recommending things that are not applicable for health and safety. We take a lot of time to ensure that the right things are put in the right place, so we won't put things in that we believe are going to in any way implement any risk increase from a safety perspective.
Well, anyone else want to add to that?
Well, yeah, just add that one of my clients, security, and I represent the OT security. I'm part of their health and safety briefings. So health and safety and security are very much collaborating and communicating and aware of the requirements of, certainly securities. I'm aware of the health and safety requirements from a security perspective.
Rich has just asked, how do you handle equipment manufacturers increasing requirements for operational data from machines?
Difficult.
So
with great difficulty.
Yeah.
Sorry,
What I think there's some way to go, and I do see development in this area, and that is third-party risk management, supplier assurance, whatever term you want to give it, being more focused on OT and ICS, because historically, if you send an automation supplier to go through third-party risk management or supplier assurance, they'd ask the question, are you dealing with sensitive data? And it would end up the risks low, because that process is protecting confidentiality, really focused on that. I think I have seen a change with OT-specific assessment, which I fed into and helped draft one of these. And that focuses on your software development lifecycle, your connectivity requirements. Do you understand the ports, protocols, and services in both directions? Are they fixed endpoints? And really focus on, the information needed, so the architecture can control the required connectivity. Because as I said a bit earlier, the amount of times I hear all it needs is internet connectivity. And you say, what ports, protocols, and services? And rarely suppliers have any idea.
Correct. I think I just want to build on Peter's point. That's what I'm going back to the culture. Just because we want information, we need information in the cloud to get that predictive analytics or performance. The suppliers don't understand what they need. They don't understand where their device is actually going to, if it's on an Azure or whatever, and they tend to not understand what's needed. And that is a real challenge when we try to connect. We'll set a firewall up or a connection up, and then it won't work. And that's a big challenge because the suppliers just say, give us the data and we'll give you value, but they actually don't know what they actually need, is my experience.
Well, I think we've got time to squeeze in one more. I know, Peter, you've already commented on this question, but Ben asked, what are the considerations for digital twins for OT and IoT? I don't know if you want to expand on your answer, Peter, or
yeah,
Ben.
Yeah, absolutely. So I often hear it mentioned, and I think you get engineers see demonstrations of this and the benefits pitched at conferences, but I haven't. You rarely see budget given to this. Maybe it's a proof of concept, and I'm sure there are industries and manufacturers and in critical infrastructure them using digital twins, but there are bigger priorities to spend a finite budget on. And it's at this stage in the maturity journey of lots of organizations I see, we're early on, and those assigning those limited finite resources are on the foundational controls: remote access, connectivity, segmentation, patch management, vulnerability management, security information and event monitoring. Budget to develop security digital twins is I haven't seen much of it. I don't know whether Anthony wants to comment on that.
I'll just build on it and say we must do digital twins in the future. The foundations of what Peter said about getting the foundational security infrastructure in place is fundamental. So money should be spent there now as a priority, but the big prize is the digital, whether it's being able to innovate quicker, whether it's to produce product quicker, whether it's to produce product better quality. Digital twins are fundamental for that. Going back to productivity of what I've just said, but please, you can't do that if you don't have the foundations. And I think we've got to make sure we focus on the foundations first to allow us to fully blossom to all these digital twins.
Well, thank you everybody for coming on to this call today. The slides and the recording will be shared in the next week or so. Again, thank you, Peter, Ben, and Anthony for your time this afternoon. Hope everybody enjoyed it. Lots of reactions coming through. So thumbs up from everybody. Enjoy the rest of your day, and thank you once again. Goodbye.
Thank you. Goodbye.
Thank you, everyone.
Bye.